The learning objectives for today's lesson is to be able to use the shapes of distributions to select appropriate statistics and use the shapes of distributions to compare data. Now imagine these are the marks a student scored out of 100 in different tests. Now the average mean, we would add all these values up to give us 213, and then we would divide by how many of these values there are. So we have 5 values, so when we divide by the 5, we would get 42.6 for the average mean. Now for the median, we need to firstly order this data set. So we can go from smallest to largest, or we can go from largest to smallest. Whichever method of ordering you use, the middle number is 43, and this is our median. Now let's replace this 45 with an outlier. Now an outlier is a data point that differs significantly from other observations. Okay, so let's change this data point 45 to 95, and if we work out the mean, we can see this is 54.6. So this outlier has had a significant effect on the mean. Okay, it's increased the value of the mean. Okay, for the median, we do the same thing. We order the data sets, and the middle number is still 43. Now it's important to remember that the outlier has a strong effect on the mean, while the median is less affected. Now the distribution of data shows the observed or theoretical frequency of each possible data value. Now imagine these 3 data sets are samples taken from different larger populations. Now if we work out the averages for these 3 data sets, we get the mean and the median is 7 for all 3 data sets. Now these are statistics. Now these sample statistics won't allow us to compare these 3 data sets in a meaningful way, because although the averages equal 7 for each of these data sets, we can see that each individual data set is different. You can see it varies here. Okay, the data is spread out about the mean 7. Okay, the data varies here even more, so it's even more spread out about the mean 7. So how do we go about measuring this spread? Well, we can use another sample statistic called the standard deviation, which allows us to measure the spread of data, and it tells us on average how much the data points deviate from the mean. Now to help us better understand the spread of data and how the data points deviate from the mean, essentially to better understand the standard deviation, we'll use a diagram. So in this diagram, these horizontal black lines represent the average mean 7 for each of these data sets. Now let's look at the first data set. We want to know how these data points are distributed about this mean. Well, you can see they all lie on the mean 7. They don't deviate from the mean. There is no spread here. So we'd expect the standard deviation to be 0. Okay, so this means on average, these data points deviate 0 units from this mean 7. Okay, looking at this second data set, we can see there's some spread of data. Okay, these 2 points deviate by 1 unit from the mean. Okay, so the standard deviation is 0.71. This means on average, these data points deviate by 0.71 units from the mean. Okay, and over here we can see a larger spread of data. Okay, so this data point here we can see deviates by 2 units from the mean. This data point deviates by 1 unit from the mean. We'd expect the standard deviation value to be higher than these two, because we can see visually that the data is more spread out. Okay, so the standard deviation is 1.58. So this means on average, these data points deviate by 1.58 units from the mean 7. Now, the shape of the distribution for a set of data can be seen by drawing a curve over its histogram, so like we can see in this diagram. Now, if you look at the symmetric distribution, we can see that the mean and the median are approximately equal, if not perfectly equal. And you can see that the data are evenly distributed on both sides of the mean. And if we look at the negatively skewed distribution, we can see that the mean is less than the median. And the majority of the data are on the right of the mean. So we can see that the majority of the data lies here, to the right of the mean. Now, for a positively skewed distribution, we can see that the mean is greater than the median. And we can see that the majority of the data are on the left of the mean. So this is where the majority of the data lies, to the left of the mean in a positively skewed distribution. Now, if you recall, outliers strongly affect the mean, whilst the median is less affected. Similarly, when a distribution is skewed, the mean lies away from the majority of the data towards the tail end. Just like we have over here, the mean lies away from the majority of the data towards the tail end, whilst the median lies near the majority of the data. Just like we have here, the median lies near the majority of the data. Now, when choosing appropriate statistics to represent a set of data, we first need to determine the skewness of the distribution. So if the distribution is relatively symmetric, the mean and standard deviation can be used. If the distribution is skewed or the data contains outliers, then we can use the 5-number summary to describe the center and spread of data. Now, the 5-number summary I'll go through on the next slide. Now, when we refer to 5-number summary, what we mean is we have a minimum value of the dataset, we have a maximum value of the dataset, and from these two we can work out the range of the dataset. And then we have the median, in which 50% of the data lies below the median, 50% of the data lies above the median. Then we have Q1, which is the lower quartile, and 25% of the data lies below Q1. And then we have Q3, which is the upper quartile, and 25% of the data lies above Q3. And these are the 5-number summary. Now, just on a final note, 50% of the data lies between Q1 and Q3. Now remember, we use the mean and median to describe the center of a distribution and standard deviation or quartiles to describe its spread. Now, for example 1, the prices for a random sample of tablets are shown over here. Part A, we want to use a graphing calculator to create a histogram, then describe the shape of the distribution. Now, I've used Desmos. So in the first line, you type in L equals square brackets and then enter your data points, separating them by a comma, and you should have 32 elements. And then for the second line, you type in histogram, open brackets, L, which refers to this data set, comma 100, and 100 will be the width of the bars. Now, make sure you select count and left, which will then give you the histogram like so. Now, the majority of the tablets cost between 400 and 700 dirhams. Some of the tablets, however, are priced significantly higher, forming a tail for the distribution on the right. So this is a positively skewed distribution. Part B, describe the center and spread of the data using either the mean and standard deviation or the 5-number summary, and then justify our choice. So, since the distribution is skewed, we use the 5-number summary, which is over here. Now, the prices range from 374 dirhams to 915 dirhams. The median price is 530.5 dirhams, and half of the computers are priced between 451.5 dirhams and 665 dirhams. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
A box and whisker plot can be used to identify the shape of a distribution. So we have the box here, and this line here, the position of the line represents the median and it indicates the center of the data. And we have the whiskers to the left and whiskers to the right. Now these whiskers show the spread of data. Now the median is positioned such that 50% of the data is distributed to the left of the median and 50% of the data is distributed to the right of the median. Now the IQR stands for interquartile range. The IQR is equal to the upper quartile subtract the lower quartile. And we can use this to identify outliers. So outliers are data that are more than 1.5 times the IQR beyond the upper and lower quartile. So if we did 1.5 times the IQR and added this onto the upper quartile, anything beyond that would be classed as an outlier. Similarly, if we did 1.5 times the IQR and subtracted this from the lower quartile, anything beyond this would be classed as an outlier. Now, all outliers should be plotted, but the whiskers should be drawn to the least and greatest values that are not outliers. Now, imagine we have an outlier here. This whisker here should be the greatest value in your data set, which is not an outlier. Say the outlier was here, then this whisker should be the least value in your data set that is not an outlier. So now what we have here is a symmetric distribution, and the data are equally distributed to the left and right of the median. Now, if one whisker is longer than the other and the median is closer to the shorter whisker, then the distribution is skewed. So if you look at this one, we can see this whisker is longer than this whisker here, and the median is closer to the shorter whisker. Same thing here, we have this whisker being longer than this whisker, and the median is closer to the shorter whisker. Now looking at the negatively skewed distribution, the data to the left of the median are distributed over a wider range than the data to the right. And we can see that this is a wider range compared to this range over here. And the data have a tail to the left, so we'd have a tail to the left over here. Now for a positively skewed distribution, the data to the right of the median are distributed over a wider range than the data to the left. So we can see here this data is distributed over a wider range compared to this data to the left over here. And the data have a tail to the right. Example 2. The students in Mr. Osama's language arts class found the average number of minutes that they each spent on homework each night. This is the data. Part A, use a graphing calculator to create a box and whisker plot, then describe the shape of the distribution. Now using Desmos, in the first line, enter L equals square brackets, and then enter your data points over here, separating them with a comma. You should have 24 elements. In the second line, type in box plot, open brackets, L, and this L refers to this data set here. Make sure you select to exclude outliers, and you should have a box plot looking like so. Now, if you look at the length of the whiskers, you can see that they are approximately equal, and the median lies in the middle of the data. And this indicates that the data are equally distributed to the left and to the right of the median. So this is a symmetric distribution. Part B. Describe the center and spread of the data using either the mean and standard deviation or the 5-number summary. Justify your choice. Now, we use the mean and standard deviation to describe the center and spread since the distribution is symmetric. Now, these are the values we obtain. So we have the mean of 53.5. Okay, and then we have two possible values for the standard deviation. Now, S sub x, this is the standard deviation for the sample. And sigma sub x is the standard deviation for the population. Now, what we have here, this is the population. Nowhere in the question does it suggest that this is a sample. So when we're looking for the standard deviation for this particular question, make sure we use this value here in green for the standard deviation. So now we can say that the average number of minutes that a student spent on homework each night was 53.5, which we can see here, with standard deviation about 10.5. So we've rounded this value of the standard deviation to one decimal place to give us 10.5. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now for example 3, the test scores from Mrs. Amel's class are shown below, so you can see them here. Now, part A, use a graphing calculator to create a histogram for each dataset. Then, describe the shape of each distribution. Now, whether you use a graphing calculator or a graphical software, your histograms should look like below. You can see that the width of the bins are 5. Now, if we look at these two distributions, we can see that it indicates that the distributions for both of these two datasets are symmetric. Part B. Compare the distributions using either the means and standard deviations or the 5 number summaries. Justify your choice. Now, since both distributions are symmetric, we use the means and standard deviations to compare the data. And here are the values. Now, because this is a population, we use sigma x for the standard deviation to compare these two values. Now, you'll notice, whilst the Chapter 4 test scores have a lower average compared to Chapter 3 test scores, it also has a smaller standard deviation. And this indicates the scores are more closely grouped about the mean. So what this means is the mean for the Chapter 4 test scores is a better representation of the data than the mean for the Chapter 3 test scores. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Example 4. The points scored per game by a professional team for the 2008 and 2009 football seasons are shown over here. Part A. Use a graphing calculator to create a box and whisker plot for each dataset. Then describe the shape of each distribution. So here are the box plots. This circle indicates an outlier. Now for the 2008 scores, the whisker on the left is longer than the whisker on the right, and the median is closer to this whisker on the right. So we can say that the distribution is negatively skewed. For 2009, the whisker on the right is longer than the whisker on the left, and the median is closer to the whisker on the left. So we can say that the distribution is positively skewed. Part B. Compare the distributions using either the means and standard deviations or the 5 number summaries. Justify your choice. Now these are skewed distributions, so we'll use the 5 number summaries to compare the data, which we have over here. Now if we compare the median points scored, we can see for 2008 it was significantly higher. Then if we look at the interquartile range, which is essentially the box length that we have here, the interquartile range for 2008 is smaller, so this shows the scores are more closely grouped together about the median. Now, if you look at the lower quartile for 2008 and the upper quartile for 2009, they are both equal to 20.5. So we can see that for 2008, 75% of the scores were greater than 20.5, and for 2009, 75% of the scores were less than 20.5. So we can conclude that the team scored a significantly higher number of points during the 2008 season than in 2009. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following.